Okay, so today we're going to talk about the main concept in chemistry, which is known as the mole. So before we get to the mole, let's talk about other counting numbers that you are familiar with. All right, so let's say I walk into a shoe store. So let me think of a shoe store here, like Foot Locker, or if I go to DSW and buy me a nice pair of designer shoes. Shoes, when you buy them, come in pairs. Let's talk about going to the grocery store. So I go to the grocery store and I want to buy eggs. Okay. And for the most part, eggs come in a counting number called the dozen. Okay, so we should know a pair means two, a dozen means 12. Let's say I go into Office Depot and I buy a package of paper. And this is typically known as a ream, so like 500 sheets. Now, when I go into the chemistry store, we can buy a mole of something. And since we're just kind of starting out in chemistry, the only thing we really have talked about in depth at this point is the element. And we know the element's smallest particle is the atom. So when I buy atoms, I'm buying a mole of atoms, which gives me 6.022 times 10 to the 23rd atoms. And so this is the relationship we're going to look at today. So we're going to be working in the next couple of lectures on a flow chart. And in our flow chart, we're going to look at relationships involving the moles. So here's the one we know today, that I have this bridge known as the mole, and my bridge can get me to particle land. And at this point, the only particle we know is the atom. And so the relationship we're going to use is that 1 mole is equal to 6.022 times 10 to the 23rd atoms. So this is going to be our conversion factor, which means we're going to be using dimensional analysis again in this chapter. All right, so we're going to look at a couple of problems. All right, so here's my problem number 1. I would like to know how many moles of carbon are in 2.25 times 10 to the 22nd atoms of carbon. Okay, so when I look at my problem, I can see the unit moles and I can see the unit atoms. And so my conversion factor that I know involves moles and atoms. So we're only going to have one conversion factor. So remember about dimensional analysis. So my given is whatever I know the number and the unit of. So I'm going to put my 2.25 times 10 to the 22nd atoms of carbon here. Okay, now notice in this section that not only am I labeling it with the unit, but also the substance. And this is really important because we're working towards using the mole when we get to chemical reactions. And in those problems, we're going to be converting between different types, different substances themselves. All right, remember we can put our given over 1, and that 1 doesn't have any units. It's just a placeholder. Or you can even leave that square blank if you'd like. We want atoms of carbon to cancel. And the unit I'm looking for is moles of carbon. Okay, so if I go back and look at my relationship in front of moles, we're going to put a 1. And in front of atoms, we're going to put the 6.022 times 10 to the 23rd. Okay. And this number is actually known as Avogadro's number. Okay, then we're ready to solve because my atoms are going to cancel and I'm going to have moles of carbon. So we're going to multiply across the top. So anything by multiplied by 1 is still itself. And we're going to multiply across the bottom. Okay, so you may want to pause your video here to make sure you have your calculator out. I'm going to walk you through the buttons you're going to press on your calculator. Now remember that instead of this times 10, we're going to be using this EE function on your TI calculator. All right, so here we go. 2.25, and that EE is probably either second and the comma if you have a graphing calculator, or second x to the negative first if you have a TI 30. And then the power of 10 is 22. I'm so sorry. Okay. And then we're going to hit the divide sign, and we're going to enter in Avogadro's number. So 6.022. And then again, you're going to use that EE function and the power of 10, which is 23. Now, my calculator is not in scientific mode, so it's giving it to me normal notation. So you can give answers in normal or scientific notation. I'm going to give it to you in both here. So remember that we're looking at what's in front of the times 10 to determine sig figs. So the given has the fewest, it has 3, so my answer is going to have 3. So in normal notation, there's leading zeros. Remember, those leading zeros are not significant. So then I need 3 sig figs after those leading zeros. So I got 3, 7, 4, and my unit is going to be moles of carbon. If you have it in scientific mode, you're going to have 3.74 times 10 to the negative second moles of carbon. Okay, so that's problem number 1, where I'm giving you atoms and we're converting to moles. Let's look at problem number 2. Okay, so in problem number 2, I want to know how many atoms of sodium are in 3.80 moles of sodium. Okay, so my given is whatever I know the number and unit of. So that's what we're going to start with. And MOL is actually the abbreviation for moles. And we can put our given over 1. That 1 is a placeholder. It doesn't have any units. When we use dimensional analysis, we're going to cancel out units. So I need that moles of sodium to cancel. So it's going to go in the bottom. And if I go back to my question, it wants to know atoms of sodium. All right, so you go back up and look at your notes and look at that relationship. You're going to see that the number in front of moles is going to be a 1, and the number in front of atoms is going to be Avogadro's number. Okay, so you'll be responsible for memorizing Avogadro's number and this mole relationship for our test for the rest of chapter 3 and probably chapter 4. Now, in this problem, everything on the bottom's a 1. So we're just going to multiply the numbers on the top together. Right. So again, I'm gonna walk you through the numbers on your calculator. So 3.80, then we're gonna multiply by 6.022. And then again, we're not gonna use this times 10. You're gonna use that EE function on your calculator, and then the power of 10 is 23. All right, so let's talk sig figs. So we know whatever in front of the times 10 has significant figures, so there are 4 there. Our given has 3. This trailing 0 is significant because of the decimal in the number. So it looks like I'm going to have 3 sig figs in my answer. I'm going to have 2.29. Now here's where you have to be careful. You want to look all the way to the right of your screen and notice there's an e to the 24th. So this means we need times 10 to the 24th in my answer. My mole unit would have canceled, and we're going to have atoms of sodium. All right, so that's our first mole conversion lesson. We will have, once we've covered all the mole conversions, we'll have some office hours if you want to get together and ask some questions. All right, so your job today should have been to copy down the notes so that you have them.